So considering our question, in this case, we are given that is to draw, number one, draw the circuit diagram, including component values, all right, of the network shown in Fig 1.8. We are given the impedance network, like that is the impedance, the impedance, the impedance. And from this, you are asked to present in terms of the component values. Terminals A and B are connected to an AC voltage source of 100 volts with a frequency of 50 hertz. We are given the voltage affected at the end. So this is it. Remember that if you are to work with your components, you need also to understand this in terms of our impedance. Z can be given as R plus JXL, or it can be given as R minus JXC. This is what we understand. Meaning to say, wherever I see a positive, it simply shows that that is having an inductive circuit. It was having a resistor, and the reactance there is of the inductor. We are talking of what? The inductive reactance. For any part that has a positive. For a negative, what does it show? It shows that whenever you see this negative, the following component there is supposed to be a capacitive. Supposed to be capacitive. The reactance there. All right, so this is it. Let's figure out. We have this in parallel there to a parallel combination. There it is in series, then connected to a parallel. Let's start with here, 20 plus J, 25. There's a plus here, meaning to say we have got Z, which is equal to R plus JXL. Remember what I said. All right, I'm just going to attempt my question here for the calculation so that we do not get away from our diagram. So meaning to say, from this part, we already have resistance and XL. So I'm just going to call this Z1. I'm going to call this Z2. And I'm going to call this Z3. All right. So Z1 is equal to 20 plus J25, where this 20 represents the resistance. So it's R plus JXL. So meaning to say, we know the resistance that it is 20 ohms. The component, there's a resistor there. Which other component? Inductor, XL, reactance. So we've got XL there. So we have got XL. From this, we also have XL, the reactance, which is 25 ohms. We have the reactance, but we need the component now. Which component is it? The inductor. If you've forgotten this, go back to your XL, 2 pi FL. So you can make L the subject there because you need the value of the inductance. The component there is supposed to be the inductor, capacitor, or the resistor. These are the components of the resistor. Okay, so we saw that from our XL, we can we are given this as XL is 2 pi FL. So meaning to say from here, we can calculate our L, just divide by what? By 2 pi F by 2 pi F. Guys, you're back to your mathematics. So it was going to be XL over 2 pi F, just like that. So you can substitute. We have got our XL, guys, which is 25. So this is 25. Everything over 2 pi times the frequency. We are given that across this, there's a frequency of 50 hertz. So the frequency is given. There's a frequency there of 50 hertz. So that was going to give us the value of L that is going to be L1. Since this is Z1, so you're just going to call this R1, and this is going to be L1. All right, guys, on our calculator, I can just fix this. I'm just going to fix my calculator to 3 decimal places. Remember, guys, I showed you shift, setup, fix, then you press 3. If you want to 3 decimal places, it's going to be 25 over 2 pi, then multiply to 50. So that was going to be 0, 0,08. Okay, just going to write this as 0,08 like this. There's a 0 there. Do not worry, guys. This is like a direct value, guys. Whatever that we are obtaining there, it's a direct value. All right. That is, we are obtaining something that is direct. In some cases, you might have a condition where you have got those decimals like, no, this one is a direct value. If you want to write in, maybe it's you want to write in milli 1, 2, 3, so it's going to be given as 80 millihenries, something like that, depending with the way that you are presenting it. This is a direct value. So that's 0,08. You can just leave it like that. So this is our inductance in henries. So this is to 3 decimal place if you are working with the 3 decimal place concept. So meaning to say, on this Z1, we have a resistor and we have also the inductor. Okay? That is what we have on Z1. So let me just remove this and write our inductor. L1 is 0,08 henries, or you can write it as 80 millihenries. Let's move on to the second part, or to the second impedance that you're given. What is the reactance there? There is a minus, so that is a capacitive. Remember, Z is equal to R minus JXC. Once there's a minus, it's XC. So meaning to say from our Z2, which is 15 minus 15 ohms. 15 here is for the resistance. And this other 15 is for the reactance of the capacitor XC. So resistance is 15 ohms. XC is 15 ohms. But we do not need X, we need the capacitance. The component there is the capacitance. So remember that from your formula sheet, we saw that XC is given by 1 over 2 pi FC. It also follows that if you want to calculate C, C is given by 1 over 2 pi FXC. So it was just going to be a substitution 1 over 2 pi times the frequency. Remember, our frequency, we said it's 50 hertz. So that is 50 times XC, which is 15. So we just make this the subject, guys. That is, we are going to obtain your capacitance in that case. All right, so let's see, guys, what are we going to have with our calculators to 3 decimal places, depending with the instruction that you'll be given in exam. Okay, so this one was going to affect because of the rounding off. Let me just use as it was, go back to the setup, then go to the normal. So just going to press 2 so that it gives us like all the values that we can see. That's 2, 0, this. So remember that normally capacitance, you round off to the microfarad, and microfarad is 10 to the exponent of -6. So the opposite now, to express that, you multiply by the opposite, which is the inverse, by 10 to the exponent of a 6. So if you multiply this answer here by 10 to the exponent of a 6, it is going to give us 212, that will be 207. This will change to 207. The answer there is automatically in the microfarads. By multiplying by 10 to the exponent of 6, you are converting direct to the microfarad. Micro is times 10 to the exponent of -6. So to convert to this, you multiply by a positive, not by a negative, the opposite of that. So that is, you must be careful there. So this is it. We have got the capacitance. So this here is not important. We need the capacitance there. So our capacitance, I'm just going to write R2. The capacitance C2, since it's the component 2 that we are talking about. So it is 212,207 microfarad. That's it. From the XC, we can calculate the capacitance. Let's see the other component. There is impedance 3, Z3, in this case. And our Z3 is given by 10 plus J10. A plus. I talked about this. A plus means the other component there is inductive. So we've got the resistor, which is 10. So meaning to say our resistance is 10 ohms. And this will represent XL, inductive reactance, which you need now to calculate the inductance, just like what we saw there. Inductance is going to be XL over 2 pi F. So we are going to have our inductance from XL over 2 pi F. So that is XL 10 over 2 pi times the frequency. Remember, the frequency is 50, guys. We are given this. Let us simplify this direct. Remember, I now have my calculator in the normal mode. That is 10 over 2 pi times 50. So this will be like this, guys. You can even just round off to 3 decimal place, guys. Okay, so that we do not have have confusion. Like the other one, we just use it like that. So it's gonna be 0.032. Just gonna use it like that. 0.032 henries. Or if you use the previous one, you're going to maybe have it in millihenries, which is fine, which is actually perfect. You can do it like that, okay? It's one and the same thing. So that is what is important, is that we have got this component, okay? So we've got the inductance, 0.032 henries. That is all the components are there. So that's for the third one. It's just going to be R3, L3. Now let's check. We need this to, remember the question is for us to draw the circuit diagram. So it means that from A to this, we need a diagram. Well, how is going to be this? Okay, let's have it. From A, this will be our circuit diagram now. So our circuit diagram, as we can see, the component, the first part, our impedance 1, it is a resistor and an inductor. So we are going to have a resistor like this. Just going to have our resistor with an inductor. All right. So we're just going to have our inductor like this. Remember, it will be an RL circuit. This one is going to be an RL circuit where there is a resistor. So this is just going to be R1 and this is L1. So there we are writing the values, the resistance, which is 20 ohms, the inductance, that is 0.08 henries, or you can just write whatever way that you understand, guys. Is it in millihenries? It's up to you. So this is it, the first part. But how is it connected, this Z1? Because we have presented Z1. Z1 is connected in parallel to Z2 and Z3. So we are going to have a parallel presentation from here. So you're going to have a parallel connection, okay? Connected to Z2, which consists of a resistor and a capacitor. There's a resistor and a capacitor there in this circuit. So meaning to say we are going to have this, a resistor and a capacitor. So we have got a resistor there and we also have a capacitor. So these are two components that we have on our Z2, representing our Z2, the whole of this Z2. So you've got a resistor. So I'm just going to write this as R2, which is 15 ohms. Then this is our capacitor. In our calculations, like this is the only capacitor, like this is Z2, but according to our presentation, that is the only capacitor. So we're just going to write as this is C1, all right, which is 212.207. I hope you understand what I'm trying to say here. There I was just presenting like this is Z2, but on our diagram, there's only one capacitor there, okay? Then we move on to this other connection. Remember there we had an inductive, a plus. So our Z3 is inductive. So there's another inductor. So this will be inductor 2. Remember, there is inductor 1, and this will be our inductor 2. There were 3 resistors there, which is fine. So the resistors, they are fine. But the inductor, in this case, for the inductance, I'm just gonna have this R1, R2, this is R3, okay? Which is this one, the 10 ohms. So this will be 10 ohms. So here, since I have this inductor 1, I'm gonna write this as my L2, which is representing that L3 that you had from that part. Do not worry about that. So that is 0.032 henries, just like that. So this is it, but there we are told that this whole connection is connected to 100 volt, 50 hertz. So we must connect to an AC. So this is connected to an AC. Okay, that's gonna be like this. So you're gonna have our AC, in this case, having a total voltage of what? The source voltage is 100 volts. So that is our total voltage, which is 100 volts. All right. And the frequency, 50 hertz. The frequency affecting this voltage is 50 hertz. So the frequency there is 50 hertz. That is the idea. We have got the circuit diagram. So this whole part here that we are seeing represents Z1. This whole part that we are going to have here will represent Z2. This whole part will represent Z3. But now we are writing as components. So it's no longer like Z1, Z2, because we now have inductor. We have to calculate the reactance to have Z1. Calculate the reactance of this, you combine, you have Z2. You combine this, you have Z3. Do you understand the concept? To break up this circuit, how is it presented? So just understand this. Because in the exam, you see in the formula sheet. This is what you have in your formula sheet. Just understand plus XL, inductive. Minus is for XC, that's capacitive. Then from there, you can calculate whatever you have got. The formula for XC, manipulate that, make C the subject. Your formula for XL, manipulate that, make L the subject. That's the idea there. All right. Then the other part of our question is 2. We are given them now to calculate the impedance at 50 hertz, meaning to say still at the same frequency that you're given between A and B in complex polar form. The answers are needed in polar form. Okay. We need the impedance. So guys, this is it. These impedances are already there, Z1, Z2, Z3. So the question is, how are we going to calculate the total impedance? How are we going to calculate this? We do understand that This is connected to a parallel combination. So our ZT in this case was going to be given as Z1 plus you are adding that of the parallel combination. But how do you calculate in parallel? Remember, in parallel does not change, guys. Product over what? Over sum. So meaning to say this was going to be Z1 plus the product over the sum, the product of these two, Z2 and Z3. Z2 times Z3 over the sum of Z2 and Z3 over the sum. Remember, I said that as long you are working with this type of a question, you are limited to an extent that you need both formats, the rectangular and the polar form. In calculation, yes, the question needs you to write your answer in polar form. Remember, multiplication is best in polar form. Addition is best in rectangular form. So meaning to say we are forced to convert all these to polar form because there is a part where you are going to need that polar form. So we need to have our Z1 also in polar form. As we had it in rectangular form, it's already in rectangular form. We are going to need it in polar, which will be arctan there over B, B over A. Sorry for that. That is our network is also affecting us here. So that is, we have got the format that you can use, or simply you can convert direct on your calculator, guys. I talked about this. That's you have your polar, and you just press this 20 and 25 separately. You've got your answers in polar form. So that is, you were going to obtain 32.016 in this case for this one, and also the angle was going to be 51.340. All right, so which is 34 in that case. All right, so you do the same thing on each and every part that you are given. Also on your Z2, you need also this in polar form. Okay, so you can use this formula direct, or you can simply apply the conversion on your calculator to confirm if you are on the right direction on your calculation. So that was going to give us 21 comma. All right, so this is gonna be 21,213. Then the angle was going to be negative 45. In that case, you're going to obtain negative 45 degrees, okay? So you do the same thing, guys, on each and every simplification. Also here on Z3, you're going to have the same application. You convert to the polar form in that case, so that you're gonna have this as 14,142. Then the angle was going to be positive 45 degrees. All right. So the conversion there is in your hands, guys. The conversion part is in your hands. Let me just remove this. Yes, disturbing us. We do not need this. All right. So like I said, this is where we are. Our formula states that we need this. Okay. So this is what you're going to have, meaning to say our Z team is going to be Z1. Since it is going to be added to whatever that you're going to have here, just because you are to add, do not waste your time writing Z1 in polar form, because it must be added in rectangular form. Remember, I said addition is easy in what? Rectangular. So we're going to take our Z1 in rectangular form, 20 plus J 25. So we are going to have 20 plus J 25 plus the product in polar form, addition, rectangular form. If you note that, you're done, guys. So Z2 and Z3 must be in polar form for us to multiply. So we are going to take our Z2, the one that we converted there, okay, and also our Z3. All right, so guys, I'm just going to minimize so that we can see everything there. So this is 21,213 at an angle of minus 45 degrees divided to, sorry guys, sorry. We need the product. So this is our Z1 times, our Z2 times our Z3. Our Z3 there, which is 14,142 at an angle of what? Minus 45. That's a positive, this one. So that's it. The product of Z2 and Z3 in polar form. But addition has to be in rectangular form. So we're going to take our Z2 as it is in rectangular form, 15 minus J15. So that's 15 minus J15 plus our Z3. Remember, it was 10 plus J10. That is 10 plus J10. So that's it. We are going to calculate our total impedance from this. We are going to just leave this as it is, 20 plus J25 as it is, this one. Then we move on to the other part, which is now, yes, we are adding, which is true. We are going to add, but what are we adding? There's a product there, which we need to consider. There's a product that we need to consider, and this product is in what? Polar form. Remember, product, just multiply these numbers. So you're going to multiply these two numbers together. That is going to be what? Let me just try also show my calculator there. I fixed it to 3 decimal places. So just going to multiply 21,213 times 14,142. So that's it. You're going to have 299. So that's plus 299,994. Then the angles, remember, you must add. So it's minus 45 plus 45. Minus 45 plus 45, that's what? That's a 0 there. So this will be taken at 0 degrees. Everything over what? You need to add now these two that are in rectangular form, because we know and we understand that addition is easier in rectangular form. We're just going to add these two in the real terms. 15 plus 10, which is 25. The imaginary on their own. So minus 15 plus 10 is minus 5. So that's minus J5. So the question is, how are we going to simplify further now? Division, as we do understand, must be done in polar form. So this has to be converted to polar form. So we're still there, guys. ZT, just going to write 20 plus J, 25 plus, already this is in polar form, so it's just going to remain as it is, 299,994 at an angle of 0 degrees. Then we have to convert this to polar form. Remember our format, guys. If you are to use that formula of the square root of 25 squared plus 5 squared, which is simply minus 5 squared, then the angle is going to be arctan B over A, which is minus 5 over what? Minus 5 over 25, which is fine. But you can just now confirm on your calculator. So remember, let us just save these guys and see straightforward. So that will be shift to polar form. 25. Separate this by negative 5. We are going to obtain 25,495. So our R there is 25,495. So you're going to have 25,495. Then the angle, our theta is minus 11. So our theta is minus 11,31. So this one was going to change and round off there. It was going to be 31 there. So take note, you are given R and theta at the same time. Using your calculator, you're going to have the same thing. So this is it. We can simplify, divide, because you're now under a division. How do you divide? These terms will be divided. The angles, you subtract. Angles, you subtract. So meaning to say, we are going to have our ZT. This one we're just writing as it is 20 plus J, 25. Plus, let us simplify this part. So you're going to divide. Remember your polar form, guys, division. We are going to divide the numbers separately, which is different from a multiplication. Which is different when you are on multiplication, you multiply separately. You divide, there you multiply. So these ones just multiply, divide as they are mean. What are you going to have? This is going to be 11,767. The angles you subtract. Remember? So that's 0 minus this. So it was going to be a positive. So that's 11,31 as a positive. Minus and minus will give you a positive there. For this to be added, we do understand that it must be in rectangular form. So you're going to need this in rectangular form. So remember, in your rectangular form, the format of r cos theta plus j r sin theta. It was going to be this, cos this plus this. Or you can just convert this direct on your calculator, all right? So guys, this one, let us just convert direct on our calculator. So this is it here. You're gonna change, you want to convert to rectangular form. So this time it's going to be shift to rectangular form. So you press this here, the rectangular on minus. So it's shift rectangular form. Press the rect here. Okay. So that's 11,767. Then to separate this angle, it's going to be shift. You press this comma here on this bracket. So that is the comma. Are you seeing the dot? And that one is going to be having that comma, and some it'll be having that comma with the colon here on top. Okay, you separate that, it will be 11,31. So it will give you in rectangular form the x and y. So that is 11,538. So you're going to have plus, it's a positive, that one. So that is plus 11,538. We move on to the imaginary part, the part of j, which is this one represented by y. It's a positive. So that's plus, we're going to have j representing the imaginary. So this is 2,308. So it's going to change this into 8. So that's 2,308 if you were to round to 3 decimal places. So this is where we are. Rectangular form for addition. It's best for us to have in rectangular form, since we do understand that all we just need here is to add the real terms separately. This real term, add to this real term. That is the idea there. So if you're to add this, you're going to obtain ZT 20 plus this, it was going to be 31,538. You do the same thing on the imaginary part. This here, there's a plus 25, where there's a J. Plus 25, there we have got a plus 2,308. So you can simply add these two. 25 and 2, because that's a positive and a positive there. So it's going to be plus J, if you add, this was going to give you 27,308. That is, we have the total impedance, but it is given in what? This total impedance that we are seeing here in rectangular form. We are having this in rectangular form. Is it our instruction? Our instruction is that we are supposed to obtain this in polar form. So we have to convert now back to the polar form. Then you can just use a calculator to prove that. Remember, to polar form, that we can have this as ZT is going to be, this is our A, this is our B. So you're going to have the square root of A squared plus B squared, which is 31,538 squared, plus B squared, which is 27,308 squared, representing our R, angle of theta. So theta is arctan. So that is arctan B over A, which is 27,308 divided to A, which is 31,538. So this was going to give us the total impedance, which is not in polar form. You can just use our calculator. Remember, I talked about this conversion. So let's just use this one. I'm just going to use the calculator there, convert direct to polar form. We have got 31,538. Okay, then separate this by 27,308. Okay, so you can use a calculator now for this so that you just obtain exact values, but you can present it like this, then on your calculator, use it like this. So this is 41,718. It's going to change. There's going to be 8 there. 41,718. Is that so, guys? 718. Yeah, this one is going to change into 8. Then theta, the angle, that is at 40,888. So this 5 is going to change this one into 9. So that's the angle. Is going to be 40,889. Okay. 5 there is going to change that one into a 9. So depending with the rounding off, how are you rounding off your answers? If you're using 3 decimal places, this is what you're going to have, representing your total impedance in what? In polar form. So this is given in polar form. Understand the question, how it is given. Understand how the question is given. So as you can see, these are just your mathematical calculations there. The formula, you just know the formula, but after this, you're back to your maths N4. It's all about your maths N4. So let's revise as much as we can our mathematics N4, complex numbers. Number 3, draw the Phasor diagram of the circuit. The Phasor diagram of the current flowing from A. This time we need the current that is flowing from A to B. So how are we going to obtain our Phasor diagram? Remember, it is just going to be from A to B, guys. Remember, this is what you had here from our presentation, from what we had. Like we've got point A and point B. So this is the total current of the circuit. So we're going to relate it to the what? To the total voltage. Remember, the total voltage is at 0 degrees. So there, for the Phasor diagram, you just need voltage and what? Total current. So the total voltage is already there. So number 3, total voltage is already there. Remember, it is 100 at an angle of 0 degrees. I talked about the Phasor diagram. You just need the angles. Anti-clockwise, that is where those angles will be given as a positive. And in the clockwise, that is where you indicate the negative angle. So we need the total current because it's of what? The current A to B, from A to B, that is the total current. So what is going to be our total current? Total voltage over the total impedance. Thus, you calculated that total impedance. Remember, all this part, we're calculating the total impedance. If you still remember, we got this. Our total impedance since we are dividing, we need this one to be in what? We need this one to be in polar form. Remember, I said for your division, it's best that you're going to have them what? In polar form. So this is your total impedance, this one, guys. You need this one. So very sorry for this. So this is what you're going to need here. Total voltage, 100 at an angle of 0. Then the total impedance, we saw that it was 41,718. This was 718 at an angle of what? This was taken at an angle of 40,889. So depending with your rounding off, the way that you rounded off your values there. So let's simplify to obtain the total current. Remember, in polar form, just divide the numbers. 100 divided to 41,417, so that you obtain your answers direct. All right, so that's it, guys. Let's see. We are almost done there. 100 divided to 41,718. So this was going to give us 2,397. So we've got 2,397. Then remember, the angle is supposed to subtract, so it's 0 minus this, which is going to give us a negative. That's negative 40,889 degrees in amps. This is the total current. We have it. So we are just going to relate it because there is that is the only current that we are going to relate. So we are just going to relate it with the voltage. We're not going to take a lot of things there for this phasor diagram. Remember, I talked about the phasor diagram that you need to consider your angles. Just like how you are presenting on an Argand diagram, your complex numbers. Remember this one. So that is the condition of the negative angle, positive, negative, this part that I was explaining. So with this, we're just going to have, let me present this way. I'm just going to try to just have a reference line. So the reference line, in this case, we do not have like anything. So I'm just going to put something like this being a broken line, and also something like this also. All right. So along this line, we have got 100 at 0 degrees. Remember, this is 0 degrees, 90 degrees. At this side, we are going this side negative. So you're going to have minus 90 degrees, minus 180, depending with the direction. Going this side, positive, anti-clockwise, clockwise, negative. So VT is direct at 0 degrees. So we are going to have this one direct in this line. All right, let me just change so that we can see it properly. It's going to be direct in this line along this 0 degrees. That is where we are going to have what? Our VT along this line. So that's our VT at what? 100 angle of 0 degrees. Then our total current is having a negative angle, meaning to say it's going in the clockwise, negative 40,8, which is just below the negative 90. Negative 90, guys. We are going this way. It's minus 1, minus 2, minus 3, minus 4, minus up to minus 90. So you can see that minus 40 can be just somewhere there. You're just approximating where it can be presented. So minus 40, you can just present somewhere there. Okay, so that's something like this. In between, from this side, going this direction will be at minus 40,889 degrees. So that is the angle separating our total current. It's a negative. So the angle there is the one that deals with everything, guys. So that's our total current there is given as what? 2,397 at an angle of minus 40,889. So that's the idea there. That's the idea there. The voltage being at 0 degrees, that is in line with the 0 degrees. If you're given another part that you consider, I talked about this, we just need to work with more questions. Just try to revise as much as you can. Like I said, do as much revisions as you can. So this is what we had, guys. We just need more questions, more practice. Do as much questions as you can. Also revisit your mathematics N4. Complex numbers are explained much in mathematics N4. So revisit your mathematics N4 so that you have a proper understanding of whatever that we are talking about. So that is what you had, guys, from Maths on African Motives. Till we meet again.